Now, let's talk about conditional probability. Okay. Conditional probabilities is, as its name said, something that happens conditioned to something else. The probability of A given that B already happened. That is called given that B already happened. We have these probability tables, and I'm going to use exactly the same table that your book, the same example that your book uses. We have men and women, and we have promoted and non-promoted. They give us this table with men, women, promoted, non-promoted, and they tell us that they are 280 men promoted, 672, 36, and 204. A total of 1,200. We have a total of 960 men and 240 women, and promoted 324, and non-promoted 876. In order from this table to create a joint probability table, we have to create, this is the joint table, and it's exactly the same. Male and women, promoted, non-promoted, but we are going to get in here, instead of numbers, we're going to get probabilities. How do I get the probability of being promoted and men? The only thing that I have to do is say 288 divided by 1,200, and that is the probability, and that is 0.24. The rest are exactly the same, and this is 0.03. I'm not going to do it. 0.66, 0.17. The probabilities inside the tables are called the joint probabilities, and this probability is the probability that is a man and non-promoted, or intersections with non-promoted. Okay, so these are joint probabilities and it's intersections. We have the marginal probabilities that by adding this number, this is 0.8, this is 0.2, this is 0.27, and it's 0.73. These probabilities on the margin are the marginal probabilities. If I add these probabilities, this probability is going to be equal to 1. And if I add 0.27 and 0.73 is equal to 1. If I add all these probabilities, the joint probabilities, also they are going to be equal to 1. Now, I want to know, what is the probability of being a man given that it was promoted? We know that it was promoted. That's a fact. It was promoted. So it is between, in this, how many? 324 over here. We have a 324 number of officers that were promoted. So what is the probability of is a man given that is promoted? That should be, equal to what? If now this is my sample space because it was promoted, so forget about the non-promoted. So the probability of being promoted, it has to be equal to the probability that is a man and promoted divided the probability that it was promoted. Okay? And that is equal to 0.24 divided by 0.27. Okay? So, and if we draw it, we have men and promoted. What is the, and this is probability of, this is men and promoted, right? Intersection. So we know that it was promoted. We know that it's a fact. This already happened. Now my sample space is only going to be this part. So what is the probability then that is a man given that it was promoted? This is my sample space. Now the probability has to be equal to the probability of men and promoted divided then of the probability that it was promoted. With this in mind, we then have this formula. The probability of A given B is equal to probability of A intersection B divided by probability of B. And the probability of B given A is equal, with the same token, the probability of A intersection B divided by the probability of A. From these two formulas, we derive the multiplication law. Remember, the addition law tells you what is the probability of A union B. The multiplication law gives you the probability. Multiplication law gives you the probability of A intersection B. Okay? And that is equal to probability of A given B times the probability of B, or is also equal to the probability of B given A times probability of A. Okay? So the probability of A intersection B is any one of these formula, because we are just getting this term from the formula. Okay, when we have independent event, okay, probability of A given B is equal to probability of A. So if A and B are independent, it means that it doesn't mean what happened in B. These are independent. So like tossing a coin, what is the probability that I have a head, given that last time I tossed the coin I have a head? It's 0.5. It really doesn't matter what is the probability. It is the probability. Okay. Let's do problem number 30 on page, which page? (175). Okay. It says, suppose that we have two events, A and B, with a probability of A equal to 0.5 and probability of B equal to 0.6, and the probability of A and B is equal to 0.4. What is the probability of A given B? And this is the probability of A and B divided the probability of B. A and B is equal to 0.4 divided by 0.6. Okay, now, what is the probability of B given A? Is equal to probability of A and B times the probability of A. And that is equal to 0.4 divided by 0.5. Okay? And are A and B independent? Why or why not? Okay, this is 2/3 and this is 4/5, 0.8. Are A and B independent? Okay, the only way that two events are independent is what? The probability of A given B is equal to probability of A. That is the definition of independent events. So what is the probability of A given B? 2/3. And what is the probability of A? 0.5. Are these numbers the same? No, they are not, so it's not independent. These events are not independent because these numbers are not the same.